All right. Here in this lesson 30-2, we're going to be covering stretching and shrinking of the quadratic parent function. We will be splitting this lesson into two separate sections, questions 1 to 3 and questions 4 to 6. Number 1 states, complete the table. F of x equals x squared and g of x equals 2x squared. We're going to start off by completing the table for f of x equals x squared. We've started this a couple of times now. We know that negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. This time we're going to do 2 times x squared. So that's going to make this 8 because we square it and then multiply by the 2. 2, 0, 2, 8. A. The graph of f of x equals x squared is shown below. Graph of g of x equals 2x squared on the same coordinate grid. Well, we've got negative 2, 8. Negative 2, 8. We've got negative 1, 2. 0, 0, 1, 2, and 2, 8. Like so. B. Identify the vertex, domain, range, and axis of symmetry for each function. We've done this f of x column quite a few times now. Our vertex is 0, 0. Our domain is all real values or all real numbers. Means I can plug in any value of x that I want. Range is going to be f of x has to be greater than or equal to 0. And my axis of symmetry is x equals 0. Let's talk about g of x. My vertex is the origin, 0, 0. My domain, I can plug in any number I want into that problem, so that's going to be all real numbers. My axis of symmetry is still on that y-axis. Oops, sorry, so that's x equals 0. I went ahead of myself. My range still has to be any number bigger than 0 because we're talking about our y values. So g of x is greater than or equal to 0. Number 2, complete the table for f of x equals x squared and h of x equals 1/2 of x squared. Well, we've done this first column quite a few times now. This is going to be 4, 1, 0, 1, 4. Now we're going to half those values. So that's going to be 2, 1/2, 0, 1/2, and 2. We're going to graph these on the same grid as f of x equals x squared. So we've got negative 2, 2. Negative 1, 1/2. 0, 0. 1, 1/2. 2, 2. Identify the vertex, domain, range, and axis of symmetry. We've done this first column. It is 0, 0. All real numbers. range is f of x is greater than or equal to 0. And my axis of symmetry is x equals 0. Vertex of that new graph, 0, 0. I can plug in any number into that equation and it will work. So that is all real numbers. There's no restrictions. There's no real world situation here. So here my h of x has to be bigger than 0 because we're talking about those y values. And my axis of symmetry didn't change. It's still on that y-axis. Let's talk about these equations. Compare the functions g of x and h of x in items 1 and 2 to the parent function f of x equals x squared. Describe any patterns you notice in the following equations. The equations for both g of x and h of x are multiplied by a positive constant to the parent function. What do we notice about the table for these functions? Well, for g of x, the y values are twice the y values of f of x. For h of x, the y values are half the y values of f of x. The graphs. The graph of g of x is narrower than the graph of x of x. Than the graph of x of x. The graph of h of x is wider than the graph of f of x. What changes did you notice in the vertex, domain, and range and axis of symmetry? The domain range axis of symmetry and vertex remain the same for all three functions. On the next slide, you're going to see a debriefing for this section. Go ahead and finish writing down questions 1 to 3, and then get your debriefing answered.